Hey everyone, Mr. Boykin here, Unit 9, Lesson 7, last lesson of this unit. So what are we looking at? Slope as a rate of change. So basically what we've got here is a line with a slope. So if we notice in part A, it says the slope, m, is rise over run, y2 minus y1 over x2 minus x1. So what you need to do is identify these as x and y, 1s and 2s in this case. I'll label it like that. It can be either, vice versa. And now what happens here is, what is y2? Well, it's 120 minus the y1, which is 40, over the x2, which is 3, minus the x1, which is 1. And we basically end up with 80 over 2, and that can be simplified down to 40. Now, in this case, because we're talking about the rate of change, we've got some units. So what was the y units? So that's the one going up and down here. It's distance in kilometers. And what are the x units? It is time in hours. So basically the rate of change, which is how fast the person is driving, is 40 kilometers per hour. So that means every 1 hour that person will move a distance of 40 kilometers. So part B, it says the distance is increasing or decreasing. It is definitely increasing as we have a positive slope, and it's increasing at a rate of 40 kilometers per hour. So part 2, basically the same thing. I've also got a positive slope, which means it's going to be increasing. So I can just go down here and put a check mark on increasing right now. And what units do we have? Okay, well, we've got the oven temperature, and it is in minutes. So basically if we look right here, the first point is starting here at time 0, and the y-intercept is where the oven temperature is starting. So it's starting at 50 degrees Fahrenheit. And then after 5 time units, which are minutes, the oven is at 350 degrees Fahrenheit. So it increased from 50 to 350, which is a change of 300 degrees Fahrenheit in 5 minutes. So if the numbers are simple like that, basically my slope is going to equal the 300 in vertical change over the 5 units, in this case, in horizontal change. And that was done by going 350 minus 50 and 5 minus 0. So the same way we would have set this one up right there. Okay, now this can be simplified down again. So in this case, if I simplify this down, the slope is equal to 60. So 60 what? 60 degrees Fahrenheit per minute. So the oven increases 60 degrees every minute. So at a rate of 60 degrees Fahrenheit per minute. All right, let's take a look at part 3. It tells us we've got a graph that's representing the amount of fuel left in the car's gas tank after it's traveled a certain amount of distance. So calculate the slope of the line. Well, we know that's m equals y2 minus y1 all over x2 minus x1. So I'm going to label these 2 points as x and y1 and x and y2, and then I'm just going to replace or substitute those values in for the variables. So y2 is 40 minus y1 all over x2 minus x1. If I do the math, I'm going to get negative 10 over 100, which can be simplified down to negative 1 over 10, which is what we want, a negative slope in this case. So if we look at part B, it says, what are the units? Well, I can see the units right here. We've got liters per kilometer. So those are the units, liters per kilometer. Part C says, is it increasing or decreasing? Well, because it's a negative slope, it is decreasing. And the rate of change. So what is the rate of change? Well, it's a negative rate of change, and the rate is 1 over 10. And what do those represent? The liters per kilometer. And the next part is a little tricky and confusing, but because there's this word decreasing, that then sort of allows me to just put 1 over 10. So it's decreasing at 1 over 10 liters per kilometer. And the word decreasing allows me to eliminate that negative, because the word decreasing means going down. If I just said it was changing 1 over 10, I don't know if that's increasing or decreasing. So because the word decreasing is there, I don't need to put the negative with the ratio that's right there. And part D says, now figure out the equation. So this is in the format y equals mx plus b, except instead of m, or y, sorry, we're going to be using n, which is identified right here. And instead of the x, we're going to be using the d right there. So it ends up being y equals md plus b. Okay, so what do I know? Well, I know m, I don't know the b, and at this point I've got points, which are the y and the x. I've got 2 points there. So the first thing I need to do is calculate the b. So I'll just use, say, point number 1 right here. So the y value, which is now represented by the variable n, is going to be 50. So this is going to be 50 equals m. Well, m is negative 1 over 10 times d, and d is the x value, which is 20, times, oops, I forgot my negative right there, times 20 plus b. Okay, and right here we've got 50 equals negative 1 times 20 is negative 20. Negative 20 divided by 10 is negative 2 plus b. And to isolate the b and solve for b, I'm going to add 2 to both sides, and I essentially cancel that, and I'm left with b equals 52. Okay, so it's starting at 52. That would be this point on the graph right there. So when y is 0, the b is going to be 52. So to create my equation, it's going to be n equals negative 1 over 10 d plus 52. Okay, so I'm just going to shrink this down a little bit and resize. There we go. All right, our class example 1 has some guy named Tyrone, and he's paid a base salary. So what a base salary is that it's the amount of money you get for just going to work. Now, if you didn't sell anything or complete any tasks, your boss would be obligated to give you that minimal amount. However, a lot of jobs are on what we call commission, where in this case you can see that this person, Tyrone, is selling electrical appliances like refrigerators, stoves, blenders, things like that. So for the more items and dollars worth of items that he sells, the more money he is going to earn. So it's in his best interest to work hard and sell a lot of items so that he can earn more money. Now it says that you can see in this case, depending on how much he sells, he's going to make more or less. So last week it says he made he made $620. So he earned $620 after selling $3,500 worth of items. And the following week he earned $680 after selling $4,250. So what we need to do is put these points onto the graph. So the earnings, we can see it's the most they've got there is 680. So I might want to go up a little bit higher, like something like 800. So I'm going to divide this like 1, 2, 3, 4, 5, 6, 7, 8. Go a little over and above that. And the amount of sales that Tyrone made were a maximum of this case 4,250. So maybe I'll go to like 6,000. So 1, 2, 3, 4, 5, 6. In this case, I'm utilizing most the graph. Now, there are no lines, and none of these numbers are going to land exactly on these points. So I'm just going to approximate where they are. So the first one is 620. So remember that each one along the bottom was going to be per $1,000. Okay, so this was basically up to $6,000 in $6,000 in sales, and we said we went up to $800 in earnings. That would be up here. So if I look at the first point, it's 620, or the X would be 3,500. So I would come along here and go 1, 2, 3, 3,500 is in between, and it would go up to and connect with 3,500. No, 620. So 1, 2, 3, 4, 5, 620. My point would be right about there. Okay, so I'm just going to take a point and put it right there, and that one is going to be at 3,500,620. And what about the other point? It was 680, so a little bit higher, and 4,250, so it was sort of like right about there. I can minimize this thing down a little bit, resize it. So that's going to be that point down there, and our other point right there. Here's our line going in between right there. So I got a line going in between those 2 points. This point is 4,250 in the X, and it's going to be 680 in the Y. Okay. Okay, and that's done. Part B, calculate the slope of the line. Well, again, what do we need to do to figure out the slope? We're going to be XY1s and XY2s, and the slope is going to be Y2, 680, minus Y1, 620, all over the change in the X, which is 4,000. Hey, when it does that, 4,250 minus 3,500. And if we do the math here, I got 60 up top, and on the bottom I have, this should be 750 on the bottom. I can reduce that fraction down to 2 over 25, and it can also equal a decimal value of 0.08. Okay. And now basically explain what the graph represents. So the graph represents Tyrone's earnings. Tyrone's earnings per amount of sales. Okay. State as a percent the rate of commission which he is paid. Okay, so 0.08, if I put that as a percentage, I want to multiply that by 100, so it's 8%. So basically, whatever he sells, he gets 8%. So if he sold $100 worth of electrical appliances, he will get 8%. Okay, so part E, calculate his weekly base salary. So remember what I said, base salary is where, how much money he makes for just showing up. Now if I follow this line sort of back here, it should end up somewhere around here crossing the y-axis. So there's no way I'm like 100% accurate on this, but it should be somewhere around 100, 200, 300, 400, between 400 and 500. So I'm guessing 400 to 500 is where what his base salary is going to be. And that is the y-intercept. So how do we calculate the y-intercept? Well, I need to basically take my equation, which is going to be E equals my y, and remember this is just y equals mx plus b, replacing y with E. The slope is going to be 0.08 times x, which in this case they're calling S for sales, plus b. Now I don't know the b, that's what I'm trying to figure out, and just like we did in the last example there, I'm just going to replace E and S with two known values here. Okay, so E is the y, which I'll just use point number 1, which is 620. So I'm going to be 620 equals 0.08 times S, which is 3,500 plus B. And let me just turn on my calculator, and 3500 times 0.08 equals 280. So 620 equals 280 plus B. So I will minus 280 from both sides to isolate the B. So we're going to get 620 minus the 280, and we get 340. So we end up with 340 equals B. So I was a little off on my accuracy of my graph, but that should be it right there. So his base salary, the base salary is $340. How does the answer to E relate to the graph? Okay, well, what did we calculate in part E? We calculated the base salary. What is the base salary? It is the y-intercept. Okay, is there any more? Whoa. Write the equation in the form E equals ms plus b. So E equals m. What was our m here? 0.08. S plus the b, which is 340. Okay, and now it says 2 weeks ago Tyrone earned 486. What was his sales for that week? So earned is right there, so I just need to replace that right here with 486 equals 0.08 S plus 340. Okay, so now I need to isolate the S. So the first thing I'm going to do is minus 340 from both sides. Cancels over here. On the other side, I end up with 641. So 146 equals 0.08 S. To isolate the S, I'm going to divide both sides by 0.08. That's going to cancel right there, leaving us with S equals, so basically his sales equals 146 divided by 0.08, and it equals 1,825. So his earnings are 1,825. Don't forget the units, which is dollars. Okay, one last part. We're looking at average speed here. So speed is going to be in some distance per time. So it says John is in a race, and after 3 hours, he has traveled 270 kilometers, and after 6 hours, he's traveled 630 kilometers. So on a grid, plot those 2 points. Okay, so time is always going to be on the x, and in this case it's going to be in hours, and this is going to be distance on the y, and it's going to be in kilometers. The time looks like we're going up to 6 hours. So if I look along the x-axis, I've got my origin starting right here, 1, 2, 3, 4, 5, 6, 7. So that's good. It's going a little bit past what I need, and it looks like we're going to 630. So if I go up, I'll go every 2 lines, 100, 200, 300, 400, 500, 650. So that works out right there as well. So again, along here, every 2 lines is going to be 1 hour. So 0, 1, 2, starting off at 0, going 1, 2, 3, 4, 5. And every 2 lines going up is going to be 100 kilometers. So starting at 0, 100, 200, 300, 400, 500 right there. And if I'm to plot these 2 points, so after 3 hours, so 1, 2, 3, the person has gone 270. So 100, 250, 270. It's somewhere around that point. And after 6 hours, they've gone 500, 600, and about there. Okay, so it looks like we've got a line going from that point, which are our origin, we're starting out to there, and then from here, now if we look at the line continuing like that straight, we can see it's not straight. It's actually becoming a little bit more steep between sort of that point that would keep it straight to that point right there. Okay, calculate the slope of the line segment joining the ordered pairs. So I've got 3 points here really. So where we started out and where we got to first, which was going to be in the x, 3 and 270, and the other one was 6, 630. So to figure out the slope of the first sort of part of the race, it'd be m equals, well, now I'm just going to have to make this one x and y 2, and my first one, which was right at the origin, 0, 0, will be my x and y 1s. So to figure out the slope, it's y2, which is going to be 270 minus 0 all over x2 minus 0. So basically I've got 270 over 3, and if we reduce that down, we get 90. So it's 90 is the slope, which is the same as 90 over 1, and the units are going to be kilometers per hour. Okay, so I'm just going to minimize that one. And let's look at the second one, which is going to do the same thing. M equals, in this case, I'll make the other one up here into x, y, 1s for the second points. And it's actually a little bit, well, it doesn't really matter. We can keep it like this. So just to show you that we can work it, whether the point is first or second, it doesn't matter which one we label. Okay, so y2 in this case is 270 minus 630 over 3 minus 6. So 270 minus 630 is going to be a negative 360, and 3 minus 6 is a negative 3. And negative divided by negative is positive, and 360 divided by 3 is going to be 120 positive. And again, the units are going to be kilometers per hour. So I'm just going to minimize this little calculation. Okay, so the first leg of the journey had a slope of 90, and the second one had a slope of 120. Okay, part C, the slope of the last one. Okay, so I've sort of done C and D right there. So what is the average speed for the first leg? It was 90 kilometers for every hour. And what was the average speed for the second leg? It was 120. And the average speed for the entire race, we would use the origin and the point at 6 hours. Part E says, by looking at the grid and without doing any calculations, how can we tell that the average speed, without looking at the grid, and how can we tell that the average speed during the first 3 hours was less than the second 3 hours? Well, essentially, without looking at the grid and the numbers and stuff like that, remember what I showed you right at the beginning, that this first part right here is not as steep as the second part. So the steeper it goes, basically the faster the person is moving. Okay, that should be the end of this. And now we need to move on to the assignment on page 601, and all of the answers are at the end of that, as usual, on page 606. There you go. Enjoy and see you in class.